So it's been a second since we've worked with 5.4. Someone want to erase the board right there for me? Anyone? Bueller? Okay, cool. Thank you. How nice. You'll get a participation point for being so nice. So, example 8. So we're solving cosine of pi over 3 plus x plus cosine of pi over 3 minus x equals 1/2 over the interval 0 to 2 pi. Thank you. So throw back to what this whole section is before. 5.4 is the sum and difference identities. So what this means is you're adding or subtracting the angles together. So you're adding and subtracting two angles together. So you have your notes, you have your equation sheet in front of you? Maybe? No? No? Cool. You do? Okay. So up here at the top, literally if you're adding angles together, subtracting angles together, this is what we care about. So notice I'm adding these angles together. So we just have to, let's just use the equation. Let's plug into the equation first. So I have cosine of, let's see, cosine pi over 3 plus x. This is what it turns into, cosine of pi over 3 times cosine x minus sine pi over 3 times sine of x. And then we're adding the second one. We're going to expand it out. So I'm following the rule, right here, the identity, cosine, cosine, sine, sine. So I'm following the identity. All right, so plus cosine pi over 3 cosine x plus sine pi over 3 sine of x. And don't forget, this is all equal to 1/2. So I just tried color coding so you can see how I expanded it out. It's two different things all at once. Yes, the whole thing is equal to 1/2. But I didn't want to have like 3 colors. Yes. Oh, shoot. Okay. You know, I knew this. Okay. So cool. Got this. Bomb.com. We had this whole conversation. Let's see. Yeah? Okay. Perfect. It is what it is. Sometimes I make mistakes and I'm dumb. There, that's better. Okay. This is the same color. Okay, perfect. Thank you for reminding me. I should know this. Okay, add to favorites. Perfect. Okay. So this left side, I expand out cosine pi over 3 plus x. The right side, okay. Dropping things everywhere. All right. The right side, I expanded cosine pi over 3 minus x. So now we get the fun part of actually plugging in and solving a little bit. So this left side, cosine of pi over 3. What is cosine of 60 degrees? 1/2. Okay. I have 1/2 cosine x minus, what is sine of 60 degrees? Root 3 over 2. Perfect. So all I'm doing is I'm plugging in where there's a number. Yes. If you see right away, perfect. What I'm trying to do is make it more abundantly clear that that's what's going to happen if people don't know. All right, and then I'm going to be adding 1/2 cosine x and then adding root 3 over 2 sine x, and this is equal to 1/2. Okay, so Andy, what were you just saying? Awesome. Those go away. Those go away. And then what about these two cosine? What is 1/2 plus 1/2? A whole. Okay, cool. So I'm left with cosine of x is equal to 1/2. Wait, what angle did we say that was? Where is cosine equal to half? At what angle? What x value? So this would be pi over 3 and 5 pi over 3. Exactly. It says over the interval, so we do not need plus 2 pi n. Because remember, we're looking for two places where cosine is going to be a half. So there's two different places, because there's two different quadrants where cosine's positive. So we have the pi over 3, which is right there, and then we have all the way over here, 5 pi over 3. Awesome. And then that was like it for 5.4. So now we're going to start 5.5 and get through a couple problems. Just FYI, tomorrow I do have you in class. We're going to try to get through as much 5.5 as possible. The 28th, next week, we're going to finish 5.5, have a day where we start going over the practice test. 29th, whole day reviewing Chapter 5 test. And then the 31st is your Chapter 5 test. Cool. So this is on the home screen on MyJag. All the due dates are on MyJag. I've told you every single time. No surprises. Awesome. Yeah, I know basketball will be out of town, but we will figure it out.
I will.
Yeah, it's all good. Yes. All right, 5.5, multiple angle and product to sum identities. So, all right, let's do a little review, little practice. If I would have sine of x plus sine of x, what is this equal to? 2 sine of x. Awesome. What if I said something like sine of 50 plus sine of 50? 2 sine 50. Notice I'm not adding the angles. Wonderful. You guys act like it's so easy. Okay, let's try another one. How about, I know. How about if I do sine of x plus x? What is this equal to? Sine of 2x. Beautiful. Okay. What if I have sine of 50 degrees plus 50 degrees? Sine of 100 degrees. So my point in showing you this is there is a difference. Notice, am I adding the angles inside the parentheses, or am I literally adding like a sine of an angle plus a sine of an angle? Or am I adding sine of the addition of two angles? Am I adding inside or outside? So this bottom one, the bottom two lines, I'm showing you, okay, well, if I have an angle plus the same thing, it's just going to be 2 times that angle. And that's the first thing we're going to go over in 5.5 is the double angle identities. So if I would have something like, oh, sine of 100, I could break that down and just say, oh, it's going to be sine of 50 plus 50. So double angle, it's this 2 theta doubles whatever angle you put in. If I put in 30 degrees, guess what? It's like I'm taking sine of 60. Well, these mathematicians found these little identities, these little equations. How do I describe this? I mean, if you have an angle, more or less, the way I'm going to ask you, I'll just be real, the way I'm going to ask you is I'm going to say, hey, find sine of 2 theta if sine is blah, blah, blah. It's going to be exactly like this example. You're just applying the identities. So with sine, you have one choice. There's only one identity with sine of your double angle. Tangent, there's only one. But notice, you have 3 choices when it comes to figuring out cosine of your double angle. And fun fact, instead of using this nastiness of tangent of 2 theta of the double angle, if you know sine of the double angle and cosine of the double angle, you can just use it like a regular tangent quotient identity, where you can do sine of the double angle over cosine double angle. Awesome. Okay, so let's get down to the nitty gritty. How do you actually do this? Example 1. If sine of an angle is 3/4 on the interval 0 to 2 pi, find sine of 2 theta, cosine 2 theta, and tangent of 2 theta, the double angle. So ideally, we're trying to find sine, cosine, and tangent of the double angle. And notice all of the equations up here, they have tangent and cosine and sine. Right now, I only know sine of the regular angle. I need to know cosine of the regular angle. That way I can plug in and figure out what the double is going to be. Does that make sense? It's like a lot of English words just like spouting out at you, and I see it just going off. In order to find sine of the double angle, I first have to find what regular cosine theta is. Following or like nah? I just want to know. I don't want to go. I don't want to plow ahead if we're lost, because that makes zero sense. All right, Ellie.
I mean, for finding cosine on the test, would you want us to
use identities?
Yeah.
Yep. So we're gonna use the identities.
Like the answer.
Yep.
So we can't use a triangle.
You can use triangle. Double check. I mean, that was chapter 4. I'm teaching you chapter 5 stuff, so I'm testing you on chapter 5. Yep. Cool. I'm trying to consolidate. I mean, it's... Okay, so what I could do, and I think I already told you this, if you really want to use a triangle that bad, I'll give you a problem where you can't use the triangle to solve it. And you have to use a Pythagorean identity. But that's not fun. You know what's fun? Be able to check your answers to know you're right. Because walking out of a test being like, I know that's right, it's a better feeling than being like, I don't know, I use the identity, whatever. You guys, little rebels. Okay. Use identities from section 1 to find cosine. From section 1 to find cosine of theta and tangent of theta. On the final, though, in December, if I don't specify that you must use identities and cannot use a triangle, you can use triangle.
Are we going to have the list?
Yeah. That would be so mean. Give it to you and then don't. I don't know who you think I am. Of course, you're going to have it on for the final. Okay. Let's use the identities. First one I'm going to use, our bestie. Sine squared theta plus cosine squared theta equals 1. I know sine is 3/4, so 3/4 squared plus cosine squared equals 1. This is a difficult one without using your calculator, without saying it out loud. What is 3/4 squared? How do you figure this out? Give it a couple more seconds. Think about it. Think about how you do it. Okay. Now let's do it. All right. So 3/4 squared. What is it? 9/16. So you can distribute the squared on top, distribute the squared on bottom. Beautiful. All right, and then I gotta get this by himself. So subtract 9/16 from both sides. So subtract 9/16, subtract 9/16. 1 is the same as 16/16. I'm only doing this because I'm running out of room. My bad. 16/16 minus 9/16 is going to be 7/16. Okay. So it's equal to 7/16. And oh my goodness, we got to square root both sides. So you see cosine is equal to plus or minus root 7/4. Now, the reason I'm only going to take the positive one is sine of theta is 3/4. Is 3/4, like, where, how do I describe this? So we are going to take the positive root because we are in the first quadrant. Yeah. So I'm only taking the positive root because I'm in the first quadrant. And so I know that because, so although, okay, sine of 3/4 could be in the first or second quadrant, but if you do inverse Remember how we went over inverse, sine inverse? Give me like 2 seconds. Okay, ready? So if I would, so sine inverse, we restricted it to the first and fourth quadrants. Sine is positive here. So where 3/4 be? The first quadrant. That's why I'm only taking the first, that's why I'm only taking the positive root. This is like really, I'm like 100% explaining this. You don't have to know why. I mean, you should, but whatever. So sine's restricted domain is from pi over 2 to negative pi over 2. We went over this in section 6, chapter 4. Right? So here is where sine is negative. Here is where the sine inverse would be positive. So since it's 3/4, right? Theta is sine inverse of 3/4. It has to be in the first quadrant. Okay, if you're like, what the hell? Cool, that's also fine, but if you wanted to know why, we only take the first, that's why. Okay, so we only take the positive. So I know cosine is root 7 over 4. Okay, cool, that's all I need to know for me to find sine of 2 theta. So sine of my double angle is going to be equal to, well, let's look above, 2 times sine theta cosine theta. Well, we know sine of theta is 3/4. We know cosine theta, we just found it, is root 7 over 4. So this means, let's see, 6 root 7 over 16. I can simplify this. I just multiplied all of my numerators together, multiplied my denominators. Simplify this to be 3 root 7 over 8. Cool.
And it's always going to be positive, no matter the case for the percent equals plus the root 7 equals. Like it's always going to be positive, it will never be negative.
I don't know where you're
Like
talking
the plus
about.
minus, like why did you put positive for root 7 over 4?
Because, so I'm looking for which, so judging by this guy right here, sine of theta is 3/4. So I know that theta, this is what I was just talking about, theta of sine inverse. Theta equals sine inverse of 3/4. And if you look at your 2 quadrants, the only 2 quadrants for that sine inverse exists are these 2. Sine's positive in the first quadrant. So it tells me I'm in the first quadrant, which means when I take cosine, it has to be positive as well, because cosine's positive in the first quadrant. Okay, yes.
For distributing the 2, did you want me to do it into the 3/4? So we do it into
No, it's 2 times 3 times root 7. So it's just 6 root 7. Yeah. All right, now I want to find cosine 2 theta. Let's see. So we have 3 options. Which one do I want to use? Let's do this one. Okay, I'm going to use this one. Let's do it.
doesn't matter what you do.
Nope, we're going to get the same answer. You guys have 3 options to use. I just picked the one, I don't know, I thought it was going to be the easiest. Because cosine of theta is some like radical and whatever. Sine of theta is nice, 3/4. Super easy to use. Because I'm not using a calculator. Whatever. 1 minus 2 times sine squared theta, well, that's just 3/4 squared. Because I know sine of theta is 3/4. Makes it a little easy to figure out. 1 minus 2 times 9/16. Oh my gosh. So that's just going to be 1 minus 18/16. Unless you want me to like simplify this. Do you want me to simplify it? Maybe. How about this? 9/8. It's the same thing. 1 minus 9/8 is just going to be negative 1/8. And then lastly, if I want to find tangent of my double angle, we can just use, like, I don't know, what do you call it? The regular quotient identity. It's just instead of having thetas, it's all double thetas, all double angles. So tangent of my double angle, oops, it's going to be 3 root 7 over 8 all over negative 1/8. Wonderful. Questions so far? So I'm fully aware we have 3 minutes left. Yes, Bradley.
For the last one, when you did the center of your cosine,
Mhm.
did you put in 3/4 the side, or does it have to be?
No, because it has to be the double. It has to be the double angle. It has to be the double right there.
What if you did like 2 times?
It's not the same thing. That's the whole point of this up here, was showing you 2 times, was showing you the difference. 2 times sine of an angle versus a double angle. Okay, so tomorrow, what I need from you guys is you get here. I won't give you quick pulls, so you won't need a hat. You get here, knock out as much of 5.5 as possible. But of course, we'll go at a nice pace. Okay, cool. Have a good day. Goodbye.